Okay, chalo, we can start this session. So yesterday we covered some MCQ. Today also we can cover some MCQs. Write down the question. A point charge plus Q. Write down a point charge plus Q is placed at a distance. Is placed at a distance. A point charge is kept at a distance d, small d, placed at a distance small d from an isolated conducting plane, from an isolated conducting plane, from an isolated conducting plane, full stop. The field at point P, the field at point P on the other side, of the plane is a point charge. I will repeat this first. A point charge plus Q is placed at a distance d from an isolated conducting plane. The field at a point P on the other side of the plane is. Options are given: directed perpendicular to the plane, and away from the plane. First bit, directed perpendicular to the plane and away from the plane. Second option, directed perpendicular to the plane, but towards the plane, Now question number third option, directed radially away, from the point charge, and last option, directed radially towards the point charge, Okay, so I will repeat once. I will only repeat the options. Directed perpendicular to the plane and away from the plane. B, directed perpendicular to the plane but towards the plane. C, directed radially away from the point charge. And D, directed radially towards the point charge. Okay, so try to understand the question here. Okay, no diagram is given, so we have to make a diagram by our own. Okay, so here try to think how the diagram we can able to form and how we will get the electric field, in which direction, and which is normal to where. Normal means perpendicular. Okay, so according to the given information, here a point charge plus Q. Okay, point charge is nothing but what here, plus Q, that is placed at a distance d from the isolated conducting plate. So isolated conducting plate means that is neutral one. Okay, this is isolated conducting plate, and here there is somewhere positive Q is kept, and this Q from this plane sheet is the distance apart. So here positive charge kept, and here isolated plate or isolated sheet is kept, and what they are saying, conducting plane, and field is at point P. Means I want to find out here, there is somewhere point P is there, field is there, on the other side of the plane is. Okay, so here find out the direction of the electric field. They are asking here to find out the direction of the electric field. So here very important thing, this is an isolated plane sheet, and here positive charge is kept. That means here we are using the concept of conduction. Okay, sorry, not conduction, induction method. Okay, so if it is neutral and it is positive charges are kept, here positive charge is kept, then all the negative charges from this isolated body are accumulated at one side, and here positive are accumulated at another side. Can you get it? So as this is positive, so electric field lines are moving towards the negative charge like this. Okay, and here these are what electric field from the charge positive q, they are radially outward, that's it. Okay, and here again these lines are what going in the towards the point P. So this is what a normal direction. So here actually the field lines are coming radially outward, that means they are perpendicular to the plane and they are going away from the plane, and that means they are going towards the point P. So here according to this explanation, check which is the answer. Directed perpendicular to the plane, yes, directed perpendicular to the plane and away from the plane, yes, they are going away from the plane. So option A is the first correct option. Okay, so like that we have to verify the answers. This is all the questions which are there in the NCERT exemplars. Okay, so copy this diagram and take the option A. Take the option A. These all are concept based questions are there. So each and every small part from this chapter is covered over here. Then write down next question. The figure shows electric field lines. The figure shows electric field lines in which an electric dipole P bar is placed as shown in figure. Which statement is correct? Which statement is correct? I will repeat this much first. Figure shows electric field lines in which an electric dipole P bar is placed as shown in figure. Which statement is correct? So option 1, it is given the dipole will not experience any force. The dipole will not experience any force. Second, the dipole will experience a force towards the right. The dipole will experience a force towards the right. Third one, the dipole will experience a force towards the left. The dipole will experience a force towards the left. And last one, last option, the dipole experience a force in upward direction. A dipole experience a force in the upward direction. I'll repeat all the options again. First option, the dipole will not experience any force. Second, the dipole will experience a force towards the right. Third, the dipole will experience a force towards the left. And last option, the dipole experience a force in the upward direction. Okay, and the diagram is given. Before this was actually question from the textbook only, old textbook, but now this question is moved towards the means this question is not deleted from the textbook, but this question is there still in NCERT, very nice question. So here the electric field is given, okay, and that electric field is like this. Okay, so this green color line shows that electric field, and there is a dipole placed. Okay, so here there is a dipole. Okay, this is minus q plus q. This is a dipole, and dipole moment is p bar over here. Now it's very clear. Okay, from this you can able to tell here this electric field is non-uniform. Okay, why non-uniform? What is a uniform? There is a electric field lines are there. they are parallel with each other, their gap should be same. Okay, but here if you observe this side, means here if you check the left hand side, the electric field lines are very closer, that means they are denser. And here at the right hand side, the electric field lines are what, little bit away from each other, that means they are their intensity is less over here. And in this situation, so from this we can conclude that this is a non-uniform electric field. So now I kept here one dipole. Okay, here minus q plus q. We know that electric field lines direction means they are traveling from positive to negative. So now here this minus q is attracted towards the towards this right side, because here we have positive electric field direction. So this negative is what attracted towards the positive. Of course, this positive is also attracted towards the negative end of the electric field, but that force means that attraction is what, very less, or it is very less as compared to the force which is exerted from the left side. Okay, so here dipole can experience more force towards the left side. Okay, so here according to this, yeah, option is third option, the dipole will experience a force towards the left. So this is what the explanation. So you should understand here, this is a non-uniform electric field, and this is force F1 and this is force F2, but here force F1 is greater than F2. So that's what force is what acting towards the more force, means it's more force or more magnitude towards the left hand side. So we can say that here the force, the dipole will move towards the left hand side, or it experiences the force towards the left. Okay, option 3 is the correct option. Take mark the option and draw the diagram and explanation. So write down next question. I hope you all are getting this. Next question, write down. This is also very important question. This is the question from NCERT exemplar. Very first question only on page 1. This question is there. Very conceptual question is there. Okay, so write down. In figure, two positive charges. In figure, two positive charges Q2 and Q3 fixed along in figure, two positive charges Q2 and Q3 fixed along y-axis exert a net electric force in the positive direction of charge Q1. Positive direction on charge Q1 fixed along the x-axis. Fixed along the x-axis if positive charge if positive charge capital Q, if positive charge capital Q is added at x, 0, x, 0, the force on Q1. Okay, I will repeat this part first. In figure, two positive charges Q2 and Q3 fixed along the y-axis exert a net electric force in the positive x direction on a charge Q1 fixed along the x-axis. If positive charge capital Q is added at x, 0, the net force on small q1 is, okay. So write down the first option. First option, shall increase along the positive x-axis. Shall increase along the positive x-axis. B, shall decrease along the positive x-axis. Shall decrease along the positive x-axis. Then C option, shall point along the negative x-axis. Shall point along the negative x-axis. Last option, shall increase. Last option, shall increase but the direction changes. Shall increase but the direction changes because of the intersection of capital Q. Intersection of capital Q with Q2 and Q3. With Q of capital Q with Q2 and Q3. Q2 and Q3 are very small, and here figures are given clearly. I will draw the figure, then you can read the question once and then I will explain you this. Okay, very important question, very conceptual question is this. Okay, on NCERT exemplar, very first question on the first page of this chapter. So here charge Q1 is placed, here Q2, Q3, okay, and they are saying both are positive, no? So this is also positive, and here one more figure is kept where they located capital Q. And here they located capital Q x, 0. These are the coordinates for capital Q. Okay. So I think everyone copied the diagram. You copied. Okay, now I will read out the question. You also can read and involve in this question. So here in figure, two positive charges Q1 and Q3 are fixed along y-axis, exert a net force on the positive x direction on the charge Q1 fixed along the x-axis. Very important. Now these both are charge Q2 and Q3. Both are positive charges here. If these two are positive charges, they are exerting a force. Okay, this Q2 is also exerting force, and Q3 is also exerting here, Q2 is also exerting a force over here. Okay, so they are saying its resultant is in this direction. Okay, this resultant is in this direction. We are supposed to take in this direction as per their information, but they are saying along the positive x-axis. So this is x-axis, and if we are going from this point towards the origin, that is positive values, no? So this force, resultant force, is going towards what? Positive x-axis. Okay, so if the positive x-axis, and if positive charge capital Q is added at x comma 0, means afterwards they added the another charge capital Q x comma 0. Okay, then they are asking what will be the means this charge on Q1, this whatever the charge is there, that is small q1. Okay, they are asking if positive charge plus capital Q is added, then force on q1. So what amount of force q1 on q1 is there, that we have to find out, whether that is increases or decreases, increases in positive axis, decreases in negative x-axis. With that we have to find out, its nature we have to find out. Okay, so if they are saying here this is positive q, correct, and here this, according to them, this force is going towards this. So what about the charge q1? This charge q1 is having whether it is positive or negative, tell me now. So here they didn't mention about the charge q1. We have to find out what kind of charge is there on q1, whether q1 is positive or negative. Getting this? So this force is what q2 is acting on q1 and q3 is also acting on q1. So here both charges are acting at q1, but q1 is going towards the positive, and there is what another charge positive q is placed at x comma 0, and still this charge q1, that force is going towards the positive x direction. That means this small q1 is attracted towards the capital Q. That means maybe this q1 is nothing but what? Negative charge. Very important, we have to find out this. They are not giving, but they gave one clue. This q is what? Positive. Suppose if this is negative, then this should repel, okay, and this direction should be there in the negative x-axis. But here the resultant force should go towards the negative x-axis, but still the force is acting towards the positive x-axis, and if we introduce one another charge which is positive in nature, still this q1 is going towards the positive x-axis. That means this q1 is what? Negative in nature. Okay, so this q1 must be what? Negative. This answer we got. Okay, so here what will happen? This resultant, this force is also acting towards the q, and both this small q and capital Q are moving towards the x-axis. That means the resultant force is what? Here increases. Resultant force is what? Here increases in positive direction of x-axis. It's very important. Okay, so once you get the value of q1, value means whether it is positive or negative, from that you can find out the answer. So here yeah, option 1 is the correct option, shall increase in the positive x-axis. Getting this? So this is what the answer. Copy everyone. आम्हाला बर्थ सर्टिफिकेट देऊन जाणार. सो 4 वाजता ना क्लास. हो. म्हणजे सोडा. 3:30. आणि बर्थ सर्टिफिकेट घेऊन जाणार. समर्थ. Okay, everyone copied this. Chalo. We'll take next question. This is also very important. Huh? Some VVIMP question. Okay, write down a small object with charge small q. Write down a small charge. A small object with charge small q. A small object with charge small q. A small object with charge small q and weight mg. And weight mg small m small g is attached to one end of the string, of length capital L attached to the stationary support, full stop. The system is placed in a uniform horizontal electric field E, capital E, as shown in figure, full stop. In the presence of electric field, the string makes a constant angle theta. With the vertical, full stop. The sign and magnitude of Q is, okay. I'll repeat this and then I will give you the option. So here, a small object with charge small q and weight mg is attached to one end of a string of length capital L attached to a stationary support, full stop. The system is placed in a uniform horizontal electric field capital E as shown in figure, full stop. In the presence of electric field, the string makes a constant angle theta. The string makes a constant angle theta with vertical, full stop. The sign and magnitude of charge small q is. So write down the option: positive with magnitude mg by capital E. Positive with magnitude mg by capital E. Second, positive with magnitude second one is positive with magnitude mg tan theta by E. Then third option, negative with magnitude mg upon E tan theta. And last option, positive with magnitude E tan theta by mg. Okay, so I wrote only the key points, but that positive negative is also very important. Okay, so positive, first option, a positive with magnitude mg by capital E. Second, positive with mg tan theta by E. Negative with magnitude mg E tan theta, and positive with magnitude E tan theta by mg. So these are the options given, and here The figure is also given over here. Okay, so figure is only, this is a uniform electric field is given, and yeah, this is the string, and here charge q is kept. Okay, here charge q is kept, whose weight component mg is acting vertically downward. Okay, and here of course the q is suspended over here to the rigid support. That means tension is generated towards this end, and here it makes an angle with this axis is nothing but here theta. Okay, so here this tension we can resolve into two components. Okay, I'll use another pen here. So tension we can resolve, this tension we can resolve into two components. One is vertical and another is horizontal. So if this is theta, then this also become theta because alternate interior angle, and this will become t cos of theta, and this will become t sin of theta. Can you getting this? So these two components we are getting here. Now here we have mg. Okay, this can you able to see? We are even in class 11 we are doing. So here t cos theta and mg both are what? Opposite in direction, and both are vertical components. Okay, so here t sin theta. Okay, so actually this t sin theta is responsible for the charge movement, that is nothing but force. Means charge movement, what this charge is moving here and there, that means there is a force is acting on that. So we know that E is equal to F by Q, and F is equal to Q into E. So here the horizontal component is what here? T sin theta, and this T sin theta is responsible for movement of force, so that I will write it as a QE. This is equation number 1. And here vertical components are there. T cos theta is equal to mg. This is equation number 2. 1 divided by 2 means equation 1 and 2 you can divide, then you will get here t sin theta upon t cos theta is equal to QE upon mg. So t get cancelled, sin by cos is nothing but what? Tan theta is equal to QE by mg. Okay, and they are asking what here? The magnitude of q. Okay, so means we have to find out the value for q, no? So q is equal to mg tan theta upon e. Okay, so this is what your answer, and which option will come? Yeah, option second with positive sign, positive mg tan theta by e. This is the answer. Okay, getting how to do this? So very important question, make it 7-star IMP. So this kind of questions are very important. Here charge is there and whose length is also capital L. So that is not required here. Always remember here charge, if it is positive then it is going away, and if it is negative then it is coming towards the axis. Okay, so copy this. समज इकडे Okay, copied everyone. Okay, chalo. Write down next question. Two parallel large thin metal sheets. Next question. Two parallel large thin metal sheets have equal surfaces. Two parallel large thin metal sheets have equal surfaces. Surface densities 26.4 into 10 raised to minus 12 coulomb per meter square of opposite signs, full stop. The electric field between these sheets is, I'll repeat up to here. Two parallel large thin metal sheets have equal surfaces. Surface densities 26.4 into 10 raised to minus 12 coulomb per meter square of opposite signs, full stop. The electric field between these sheets is a 1.5 Newton per Coulomb. First option 1.5 Newton per Coulomb. B 1.5 into 10 raised to minus 16 Newton per Coulomb. B 1.5 into 10 raised to minus 16 Newton per Coulomb. C 3 into 10 raised to minus 10 Newton per Coulomb, and last option 3 Newton per Coulomb. Last option 3 Newton per Coulomb. Okay, so I will repeat the whole question. Two parallel large thin metal sheets have equal surfaces. Surface density is 26.4 into 10 raised to minus 12 coulomb meter square of opposite signs. The electric field between these sheets is 1.5 Newton per Coulomb, 1.5 into 10 raised to minus 16 Newton per Coulomb, 3 into 10 raised to minus 10 Newton per Coulomb, and D 3 Newton per Coulomb. Okay, these are the options given. So here it's very clear and very easy question. Two parallel large thin metal sheets have surface density sigma is given, that is 26.4 into 10 raised to minus 12 coulomb per meter of opposite sign. The electric field between these sheets. So we have to find out the electric field intensity in between the parallel plates. Okay, so we know the formulas, we already did this kind of questions. So I will try to draw here. So these are the parallel sheets are given. Okay, and suppose this is sigma 1 and this is sigma 2. Okay, parallel plate are there, and here this is, we have one thin metals have surface densities, okay, with opposite sign. If this is plus, then this is negative. If one plus and one negative is there, then electric field E1 and this electric field E2, okay, for the plate 2, they all are what, in the same direction. Okay, E2 is also what, in the same direction. So here both the fields are gets added, both electric fields are get added in between the two plates. So E1 is nothing but sigma upon 2 epsilon naught. Okay, and here E2 is nothing but what, sigma upon 2 epsilon naught. So we can write net electric field is equal to sigma upon 2 epsilon naught plus sigma upon 2 epsilon naught. So 2 sigma upon 2 epsilon naught, 2 get cancelled, and sigma is given, no, that is 26.4. 26.4 into 10 raised to minus 12 and epsilon naught 8.86 into 10 raised to minus 12. So this is get cancelled, and if you simplify here, then you will get the answer here. 3 Newton per Coulomb. Okay, 3 Newton per Coulomb. So option D is the correct option over here. Okay, option D is the correct option over here. Copy this. Which question should I repeat? Okay, next question. Option D. Option D. Last option, that is 3 Newton. Option D. Have you joined? You are supposed to go somewhere, no? Okay, write down next question. Next question is very important. Mark it as a IMP. Okay. Okay, mark this question as a IMP question. Write down 4 objects. 4 objects. 4 objects. W, X, Y and Z. W, X, Y and Z, each with charge positive Q. Each with charge positive Q are held fixed at 4 points. Are held at fixed at 4 points of a square of side small d. Square of side small d as shown in figure. Full stop. Object X and Z. Object X and Z are on the midpoint of the sides. Object X and Z are on the midpoint of the sides of the square the electrostatic force exerted by objects W on object X is F, is capital F. Full stop. Then the magnitude of the force exerted by the object W by the object W on Z is option A F by 7, option A F by 7, option B F by 5, option B F by 5, option C F by 3, option D F by 2, option D F by 2. I'll repeat this entire question once. Just check. 4 objects W, X, Y and Z, each with charge plus Q, are held fixed at 4 points of square of side small d as shown in figure. Objects X and Z are on the midpoint of the sides of the square. The electrostatic force exerted by the objects W on the object X is F. Then the magnitude of the force exerted by the object W on Z is option 1 F by 7, 2 F by 5, C F by 3 and D F by 2. Okay, so figure is given. This is very important question. Mark it as a IMP. Today I covered some classic questions, okay, which are very much conceptual based questions are there, where you have to apply whatever the concept you learn from the textbook, that you have to apply. Okay, so if you are solving this kind of question, then logic is what started building. Okay, then only you can solve variety of questions, or if they are asking the same question in different way also, you can able to solve. Okay, so how and what we are teaching, what we are learning, just focus, okay, and try to apply and find out the answer. So here figure is given. Okay, so one square is given here. This is what the square they gave. Okay, and just wait, let me check. Yeah, so here we have W. This corner is given W. This is what Y. Okay, and at the mid there is a X. At the mid here we have X, and here we have Z. Okay, and as this is a square, the each side is given D. X and Z are kept in such a way that means they kept at the midpoint of each side. Okay, means YZ के बीच में X and here this is a Z, and both are kept at the midpoint. If they are midpoint, then square is made up of side D. Then this distance is nothing but what? D by 2, and this is also D by 2. So from W to X is also D by 2, and from X to Y is also what? D by 2. It's very clear. Okay, so they are asking here the object X and Z are shown in a exerted. The electrostatic force exerted by the object W on object X is F. Okay, so this force is acting on X is nothing but F, and then magnitude of the force exerted by the object W on Z. Okay, means this W is acting on X as well as this W is acting on Z. Okay, then here we can apply our normal Coulomb's law, we can use here. But the problem is that whenever this force W is acting on X, we know the distance, correct? Because here according to the Coulomb's law, F is acting on X. W is acting on X due to W is nothing but we know that K Q1 Q2 upon R square. Correct. So here Q1 Q2 here charges are also same on X and W are same, but the distance is here d by 2. So we can write here K Q into Q because here they are only saying charges are same and this distance is nothing but d by 2 whole bracket square. So 4kq square by d square is the force, and this force they are saying F. Can you getting my point? Okay, so 4kq square by d square, and here now the thing is that W is acting on Z. So we don't know the distance in between W and Z. How to calculate W and Z? It's very important. We don't know. But if this is a square, then this is nothing but what? 90. Correct? So this is a hypotenuse. So this distance is d by 2. This is d. Then hypotenuse is nothing but what? We can write it as d square plus d square by 4. We can write, no? And if we simplify here, then we can write 4d square plus d square divided by 4. That is equal to, I will take 1 by 2 out, and here it will come 5d square. So d square also I will take it as a d by 2 root of 5. Can you getting this? So this is nothing but what your hypotenuse. Understood? So once you get this hypotenuse, so can we calculate here F on Z due to W is equal to KQ square, and this is nothing but what? D by 2 root of 5 whole bracket square. So here we can write KQ square. So here this 2 square is 4. So 4 I will send it up. This is d square into 5. So I will write it in more generalized form, that is 4q kq square 5 into d square. Okay. Now if you focus only on this part, this is nothing but what? My force F, no? You can check this force here. 4 kq square by d square, and here 4 kq square by d square. This is F Z due to W. So here suppose this is I am taking F dash. So I can write F dash is equal to F by 5. So this is the option F by 5. Yeah, option B is the correct option. Can you getting how we are solving the questions? Very, very important questions are these. So you should try to develop your logic by solving these kind of questions. These sessions are not compulsory. If you want, you can join. Okay? Because every time I can't cover all the questions within the mentioned sessions. Okay, copy this. Okay, finished. Write down one more question. This is also very IMP question. Many times this is a typical question in pre-midterm, midterm exams they are asking. Okay, so write down an object has a charge of 1 coulomb. An object has a charge of 1 coulomb and gains 5.0 into 10 raised to 18 electron and gains 5 into 10 raised to 18 electrons, full stop. The net charge on the object becomes first option minus 0.80 coulomb, minus 0.80 coulomb, B plus 0.80 coulomb plus 0.80 coulomb, C plus 1.80 coulomb. C plus 1.80 coulomb, and last option plus 0.20 coulomb. Okay, I'll repeat. An object has a charge of 1 coulomb and gains 5.0 into 10 raised to 18 electron. The net charge becomes first bit minus 0.80 coulomb, B plus 0.80 coulomb, C plus 1.80 coulomb, D 0.20 coulomb. Okay, so these are the options. So very easy question. Object is having some charge, okay, that is 1 coulomb, and it gains, okay, gains a charge of 5.018 coulomb, 18 electron, 5.0 into 10 raised to 18 electron. The net charge on the object is how much? Okay, so net charge we have to find out on that object. Okay, so can you able to understand? Here we have one body. Okay, this is a body A. Already there is a 1 coulomb charge is there. Okay, and it gains how much? 5.0. It gains 5.0 into 10 raised to 18 coulomb of charge from someone. Okay, so here we have to find out. Suppose this is charge, we have Q1. This is Q1 is equal to 1 coulomb. Then here can we calculate Q2? Q2 is nothing but what? N into E, no? Correct? So here N is nothing but what? And E is nothing but what? It is already received this many charges, that is number of charges are 5.0 into 10 raised to 18, and this is 1.6 into 10 raised to minus 19 electron. This many, this is a value for electron. So substitute 8. Okay, 8 and yeah into minus 1, so 0.8 coulomb is what? A Q2, that is Q2 charge I am getting, and they are asking net charge. Q net is nothing but what? Q1 plus Q2. Q1 we have 1 coulomb, and this is minus 0.8 coulomb, that is 0.2 coulomb charge we have. So here option, we have option D. D is the correct option. Can you getting this? Option D is the correct option over here. Copy this question. Okay, I hope everyone is getting, and those who joined just now, they can check all the questions which I covered today. All are very important. That is your wish. I can't force anyone. If you have a time, you can check. If you don't have, check according to your convenience. Write down last question from the today's session. Write down according to the Coulomb's law. According to the Coulomb's law, which is the correct relation for the following figure? Which is the correct relation for the following figure? Write down. First draw the figure. So here figure is given. This is Q1. This is Q2. Okay. F12 bar and F21 bar. This is figure given. Okay. So options are also given. So write down the first option. Q1, Q2 is greater than 0. B is Q1, Q2 is less than 0. C, Q1, Q2 is equal to 0. And D, we have 1, means Q1 by Q2 is greater than 1 but less than 1, and it is greater than 0. Okay, so this is what the options are given. So this is the question based on the very first topic of this chapter. Okay, so here Q1 and Q2 are coming closer. That means these charges are what? Attractive in nature. It's very important how to find out the answer. Apply the steps one by one. So these are attractive in nature. Okay, so Q1 and Q2 may be positive and negative only, no? Or negative positive. So there is an attraction. Suppose if I have positive 2 and negative 1, so I will get additive. Charges are additive in nature, and I will get plus 1 coulomb of charge, correct? So value of charge is what? Get reduced, no, by 1. So here option B is the correct option. The product will become what? Less than 0, because 1 is what? Negative. Here we know that positive, positive, negative, negative, like charges, they are repelling, and negative, positive, or positive, negative, they are what? Attracting, attracted force, and their product is always less than 0. Okay, and here their product is greater than 0. Means we are getting some positive value, but here both are attracting. That means one is positive, one is negative. If you are taking -2 plus 1 also, answer will come -1 only. So anyhow, if you check by any other method, we will get Q1 into Q2 is always less than 0. Getting this? So these are the some questions I covered. If I get time next week, I can, or I will go for the second chapter question answers. I covered here also some MCQ, and yesterday's and in today's session also I covered some. Okay, so those who are joined now, they can check all the questions which I covered today. Still few are left, but I will check according to my convenience. Okay, thank you for joining. I'm ending this session.